Okay, we have some people coming in. Welcome and thank you for coming. My name is Anna Solomon. I am NextFab Sales Manager, and I'm going to be the host today. And today we're going to be talking to Ryan Hyde. Say hi, Ryan.
Hello, how are you?
Yes. And so we'll just get started in a couple minutes. We'll give people 5 minutes to sort of filter in. But just to, kick things off, if you want to introduce yourself in the chat, put your name, maybe where you're, watching from, and Instagram, it's good for us to know who we're talking to. And it's also an opportunity for you guys to connect, get to know each other. You guys are interested in the same topic, so maybe there's some potential collaborations available. To kick things off, Ryan, I'm actually going to put your Instagram link in the chat so people can start to look at your work. And then
Cool. It's like, do I get to see the audience?
No, we will not be seeing the audience. We'll just be hearing from the audience.
Gotcha.
Hi, Matthew. Nice to meet you. And
Hi,
just
Matt.
to review today, the functions we're going to be using. We're using the chat, like I mentioned. You can find that in the bottom right corner. Typically, if you're on the phone, you can swipe through a couple different screens and see the chat and interact. We're also going to be using the Q&A function that you can see on the bottom bar. This will enable you to ask questions throughout the discussion, and then our last 30 minutes, we'll be able to address them and ask Ryan directly. This is really good
What's
for
up, Kevin?
Hi, Kevin. It's really good for, specific questions, especially like as we're talking about the topic CNC guitar making. If there's questions you have about like technical aspects, put them in the Q&A. If you have business use case things that you are struggling with, we can address both of those types of topics. Just put them in as questions as you think of them. But a little overview, as we're waiting to get started, have a few more people come in. Today we're talking about making guitars with CNC. So this topic is going to be focused on Ryan's business. We're going to hear about, how he got started with guitars, but also specifically what skills you need in order to really be successful on this tool, and how you can potentially use this for an artisan-based business. The first half of this, we're going to be talking with Ryan, hearing his story, and then the second half is reserved for questions from you. So we'll be getting and addressing all those questions we hear in that second half. So, don't worry if we haven't addressed you yet. Okay, we'll give it 2 more minutes to see who else is going to come in. And just to talk about, we have 2 more webinars coming up as well for this year. So the next one is actually going to be about networking and how to get into larger stores, connect with larger vendors. And we're going to be talking with Layla from Craft Now, who has built a really incredible network in Philadelphia and the wider region. And then on November 18th, we're going to be talking again about CNC, but specifically for furniture. So John Haggerty at NextFab is our CNC expert, and he's going to talk about how he's used it for specifically cabinets. Hi, Mark. Thank you for introducing yourself. It's nice to see everyone coming in. A few people around Philadelphia.
Hey, Mark, what's up? Good to see you. Good to meet you. Or see your words today.
Yes. I'll give it 1 more minute to let a few people come in. But for those of you who are just joining, I am Anna Solomon. I am NextFab Sales Manager. Those of you who don't know about NextFab, we're a makerspace in Philadelphia. And Ryan has been a longtime user, both as a staff member and as a business person and crafts person. So we're going to be talking to Ryan today about his work. Hello, thanks for introducing yourself. And okay, we're at 1:05, so we're gonna just get started. Like most of you who just came in, you heard me mention today we're talking to Ryan Hyde, founder of R. Hyde Guitars. we're going to be addressing a topic about CNC. So basically Ryan's journey from being a hands-on maker to actually starting to incorporate digital tools into his process to make it faster, easier, all the above. Like I mentioned, there is going to be 2 sections of this webinar. We're going to hear from Ryan. We're going to interview him. As we're talking to Ryan, put your questions in the chat, in the Q&A, and we will get to them in the second half. And then in that second half, I'll be moderating Q&A from you and get to hear more about Ryan's process. Without further ado, I will introduce Ryan. So Ryan has been building and repairing guitars since 2014. After learning from and working with some of the best luthiers on the East Coast, he is now producing his own line of bespoke instruments. And I see here, Ryan, you have a degree in industrial design, so didn't always start out that way. But can you tell us a little bit about just, you know, who you are, what made you interested in this, and how you got started building guitars? Tell us a little story.
Well, I must have typed something wrong because I've been building guitars since 2004. But you could say that 2014 was when I really started to form my own company and my own identity, I think, as a guitar maker in the present form that it is now. But I got interested in guitar making because I was a guitar player, mostly a bass player, actually. And as a kid, you know, I always was very hands-on. You know, when I used to skateboard with my friends, we ended up building our own longboards and, you know, laminating them with fiberglass and stuff. So we were, you know, a bunch of makers in the making, I think, at that point. So it was sort of, you know, at the end of high school, I was really into music after being into illustration for a while. And, you know, there's all this talk of like, what are you going to do with your future, kid? Are you going to go to college? Are you going to go to school? What are you going to do? And I sort of knew that college probably wasn't the fit for me because high school hadn't been the best fit for me. But I was realizing that, you know, these instruments that I was playing were things that could be made by people. And I got really interested in the sort of technical aspects. I think, you know, a common story is that you start out with an instrument that's not very good, and you know maybe that it can be better, but you can't afford a better instrument, so you attempt to learn things about it and make it better, and I was always sort of into that tinkering thing. So I started hot rodding instruments for myself, for my friends, and then I sort of ended up charting a path and realizing that that was what I was going to do post high school and hopefully with the rest of my life. I really started to fall in love with it the more I read about it. And I had a very rosy picture of it and things like that. But I just knew that this was an avenue that I might be good at and that I was really interested in. So I decided to pursue it. And originally I was going to move to York to study with a violin maker. But I ended up linking with a luthier in Philadelphia, and his name was Victor Baker, and he was looking for help, and I was looking to provide help in exchange for knowledge. So that really worked out. But I should also say that previous to that, I took classes in high school for woodworking to get, you know, some experience under my belt, because one thing I learned quickly is that it's really tough to get an apprenticeship or even, you know, get accepted to a school or a program if you don't have these very basic woodworking skills, because the whole craft really requires that you're going to have this background in woodworking and know the basics of milling and cutting and, you know, what is flat and what is planar and all these construction techniques, you know, how to glue stuff properly, how to prepare surfaces for glue, finishing, stuff like that. So I knew that I had to get some experience in. So I got an internship at a local cabinet shop, and we made lecterns, and we made multimedia lecterns for universities like Temple, all kinds of stuff. And this is when CRT monitors were still in full effect, so these things would be enormous. You would house enormous textiles. So I learned a lot there, Made a lot of mistakes there, and got paid to learn. Really, is how I felt about it. And by the end of the summer, after my high school graduation, I was ready to hop on board with Victor. And I had the baseline of skills. He actually sort of let me hang out for a week, and then at the end of this week, he gave me a neck to build and carve on my own. And that was sort of like the judgment. So if it was good, I was going to stay and hang out and help him. And if it was really terrible, I was not going to stay. But luckily, it turned out nice, and he let me in. So working with Victor, who's still in business today, you can check him out, Victor Baker Guitars. He's no longer in Philadelphia. I think he's in San Diego, somewhere in California, nice and sunny. He's a really amazingly talented guy. For a one-man operation, he did everything by himself, right down to the finishing. And he was the first person I met that used CNC and CAD technology. And I had seen a little bit of CAD in high school. We had a CAD program. I never got into it, or I never really signed up for it because it looked like boring numbers. I was like, I don't know, that's boring. They're just drawing like circles and cogs. I don't know. But then, I meet a guy who's building guitars with the same concept, and it just, kind of blew my mind. Because I really thought that stuff was reserved for other industries or other, I thought it was like really unattainable technology that's not, what a single person can own and use in their business. I had no real concept of that. So, that was a huge part of Victor's process, and it's how he was able to make one acoustic archtop guitar like every month to pay the bills, because he could employ a machine to be the second set of hands. And he really had the expertise and the experience to maximize that machine. So he used it for everything. I mean, almost everything. But that's also, where I learned that the CNC, it's really just doing maybe the first 30% of the total job for you. As much time as they can save you, there's still a lot of time and a lot of skill required to fit these rough pieces and parts that come off this machine, and then craft them into something that's cohesive and ultimately stable, musical, amazing, that kind of stuff.
Yeah, I think that's something a lot of people often think it comes off the machine finished. But can you talk a little bit about, how you maintain, you're working on basically a bespoke line of guitars. Based on what I've seen, you rarely make the same guitar. How do you maintain sort of that bespoke nature and also use CNCs to advance your process?
So the concept of CNC interests me because of the possibility of repeatability. So I can take my design and perfect it and then make it repeatable so that I don't have to repeat that same process over and over again each time I want a result, really. Can you repeat that a little bit? Or just like...
Yeah, well, I guess you're saying you're using certain parts of your process for the CNC. Can you talk about which parts you use and which parts are not?
So one reason for getting into the CNC would be production, right? It's ease of production and ease of repeatability. You create your file, and if your file is very good and your machine is well set up and well oiled and in tune, then the machine can repeat this design over and over to very exacting standards, and that's difficult to achieve as a human. It can take a lot of time to get an exactly repeatable result. And in guitars, where a 64th, the smallest measurement on a ruler, that's big. Gaps or distances the size of or thickness of a credit card, those can make a huge difference in how an instrument feels and plays. So you want that repeatability, and you don't want to kill yourself trying to get there. So in one way, the CNC does allow you to enter that arena of really repeatable perfection as someone who might not have like the hand skills to achieve that repeatable level of perfection each and every time. And the second half to this origin story is the 3 years that I spent at Ken Smith, and that's where we did everything by hand, and we did repeat basically 2 or 3 flavors of the same instrument every day, and you develop something in your hands that allows you to do that after a while. But I think you have to put yourself in a situation where you are physically repeating those motions to build that muscle memory. So, that's sort of a unique experience and a long experience. So a lot of people don't have time for that in their product, or sort of you can just skip it with a CNC in a lot of ways. If you're good at programming and stuff like that, if you're good at visualizing what you want to get out of the machine and you know what the machine is capable of, then you can really have it do all that specialized stuff. And you don't have to technically be the master woodworker, although one of my key pieces of advice is you do want to know these core hand fundamentals and basic woodworking fundamentals. You want to have handled a handheld router, and you want to have done these things the old-fashioned way, not just for the respect you gain for the machine, but for the understanding of the material and the tools, because really, the CNC is sort of replacing your hands in a lot of these operations.
So that being said, I know you brought some visuals. Can you just walk us through, what your process is when you're designing a guitar, bringing it to the CNC? What are the steps and what are the skills you need in each of those?
Yeah, I can sort of hop into that. Can I share my screen here?
You should be able to.
I think I'll just share the whole thing, if possible. All right, so I'm going to try and think about where to begin. I think where to begin is that everything is going to start with a drawing. And this drawing, this is CAD, and I think this deserves sort of its own introduction and a couple basic concept introductions. So one concept here is CAD, and CAD is computer-aided drafting. So that is drawing stuff on a computer, and there are multiple benefits. Number one, your drawing can you can use exact dimensions. You can have programs draw a line that is exactly this length, or exactly a circle that is exactly this diameter. So you get a huge amount of precision when drawing on a computer. The other thing again is the repeatability. As you can see here, I copy and paste a lot of my projects multiple times, and I sort of get these versions going until I've sort of worked out the different designs or changes that I encounter, stuff like that. So, and the huge thing about CAD drawing is that this line work, right? These lines on a piece of paper are useful, but you have to process all that stuff by hand. The lines that you draw on a computer can basically be almost directly translated right to a machine like a CNC. So CAD is the drafting, and then the next program that I'll show you that relates is a CAM program, which is computer-aided machining. And this is the program that tells the CNC machine how to cut what you just drew. So it will tell the machine what to cut or do with all this line work that I've sort of fit into. But, there's a whole bunch of stuff here. It's kind of wild. I think we'll look at this section really closely here. Some of the core concepts that you want to start out with at least if you're designing on a CNC, is, you know, number one, what is the shape of your part? So here's basically a fender base neck, and here's like a real fender base neck. And so I've taken this, which I probably grabbed offline or traced or something like that, and used some measurements. And then I've sort of grafted my own headstock details, and then I've made some different widths. So when I go to produce my models, right, wide, medium, and thin. Thin is like a jazz bass. For those of you who know, jazz bass has a really skinny neck. P bass has a medium or wide. Technically, you could probably get like a medium spaced jazz bass or something like that. But that's something I'm able to offer my customers really quickly and easily, because I just have these preloaded files or these preloaded drawings, and I can just send these right to you know, my CAM program, or eventually, you know, I just get the export of whatever file the CAM program makes, and then I can just throw it right into the CNC. Just put a block of wood on, cut the file, that kind of stuff. But when I do this, you know, you'll see right here I have this list of different truss rods. So I've bought all these truss rods in the past, and I've measured them, you know, fairly closely to get all their dimensions, right? Here's the actual like lug down here, or whatever the Allen key slot that you turn. And these are all dual action truss rods, because that's kind of what I use. So I'm looking at the real physical parts that I'm going to use, and then I'm copying those dimensions into this computer, into this program. And then I'm going to design my neck around that. One easy thing to do is to download PDF vector files of these kinds of things, because you can drop them right in a program like Rhino, which I guess also deserves a miniature introduction. The CAD program I'm using is called Rhinoceros 3D. I highly recommend it because it is great at drawing vectors, and it is great at drawing sort of irregular surfaces. It's also what I got my start with when Victor Baker was sort of teaching me what to do, but all these concepts are pretty similar to what he was doing. So say you've got your drawing here. What you're going to do is actually export this drawing. And this rectangle over here, this is actually the material that I'm going to use. So I'm going to import this, and I'm going to import this information. And probably the way I'm going to do it, because these files are pretty old, I haven't actually used them, is I'm just going to copy some of this information over here and take this whole sort of like combined line work object and drag it over into my CAM program. And I did a little preparing this morning, and don't show that. And I drug this over into my CAM program. So this is VCarve Pro. It's a trial edition. Both of these programs I'm using, you can download trial editions. Rhino has editions for Windows and Mac, and you can use them free for 90 days, fully enabled. You can export, you can do all the stuff that I'm going to do. And then VCarve Pro also has free trial editions as well. The export function might not work though, but you can trial your files and stuff like that. So here's the same drawing, the same set of drawings, and I've picked one. I've picked the medium. And I did a little bit of pre-processing. You can see that some of these lines over here, these are separate lines. And I sort of had to melt them together in this program. And there's a special hiccup where this line right here, I don't know if you can even see that, this small bit of overlapping line work that I forgot to clean up in my original CAD program, this was like a big no. This program was like, no. So I just did a little bit of work to edit this and clean this. I just used this little scissor guy and snipped it out, basically. And then used a couple commands, like the join command over here, to just sort of squeeze all these things together. So, sorry, My mouse wheel is like really twitchy. And tell me if I'm still on topic or off topic.
You're doing good. I think, can you explain what would happen if you didn't clean up those lines when putting it into the machine?
You just get this error message. It's just like, that's not going to work. One of the great things about this program and why it's where I started and it's kind of what I stuck with is because number one, it has a WYSIWYG, or what you see is what you get, visual preview of what you've programmed, and that has saved me so many times when sort of importing 3D files and making sure things are the right thickness, things are getting cut at the right depth. Am I accidentally going to cut something out completely and then it's going to like shake around in there while it's still running or something? You know, you want to make sure that it's going to come out as well as possible before you slap it on that machine. Because the big difference between you and the CNC machine is that, you know, you have to be a bit smarter than the machine. The machine is really dumb. You can order the machine to drill into itself. You can order it to do things that will technically destroy it and destroy your work. So you have to be really smart about using this machine, and you really have to know what it's capable of and what it is not capable of. And that, again, is where that piece of advice of, like, do this stuff by hand, because you will gain that understanding from doing it by hand, instead of, you know, crashing a machine and destroying probably a lot of money's worth of stuff. So what was that question again?
Can you take us through, you know, you're talking about you need to do it by hand before you do it by machine. Can you talk about like setting up the tool pathing and the process of the machine is to not destroy your work?
To not destroy. So one thing that, again, you know, the whole visual editor, and then the other nice thing about this program is that if I'm doing something disagreeable, or say over here with my material, this is maybe a good place to start. You know, I have my material set to 0.875, and I work in decimal often, and that's 7/8 of an inch. So that's, you know, some nominal jazz bass blank thickness. And that is literally the thickness of the piece of wood that I am going to mill and then put on the bed of the CNC machine. So in this, I can determine the thickness, tell it the thickness. I can tell it sort of what corner of the CNC to start in. You can pick different corners. The Z0 is really important because that tells the machine where to sort of calculate its height and therefore how far it drills. So there's the material surface, which is like the top surface, and then there's the machine bed, and you'll see this little guy, this little red dot moves. So material surface means the machine measures from the top of the surface, which is what I use almost exclusively. Machine bed means it touches off the surface of the bed, so you have to then take the height of the material into account. And so if you click material surface, it just does that for you. And so what that means is that whenever you're going to see another number that says 0 for the Z, that really means that it's right at the very top in parallel with that CNC, or with that material, top material. So if I say OK, and there's a couple other things, rapid Z gaps. This is like, you know, tool traveling over the material when it's doing different passes and stuff. So if you click OK, we've just set up our material, and this is really quick. This isn't everything. I'm just sort of getting a really quick overview. But essentially, you've got your 2D view, you've got your 3D view, which is right here, and we're going to sort of we're just going to reset that. There we go. We're going to get our block back. Okay. So this 2D line work, I can select this 2D line work, and then over here, this is my tool path menu. So these are all the different tool path operations that the CNC can sort of do. So this one, and it's really tough to see with my big like mouse pointer thing, it's profile. So if I want this to cut a profile toolpath, I'm going to go over here, and it's going to say, what's your starting depth? So remember when I talked about the material height, the material surface, the material setup? That's set to 0.0 because I want it to start its cutting operation right at the top of the material surface. And then for this one, I programmed it to go down 3/8 of an inch. But to be honest, I would go like a little farther and cut this whole thing out. But we're going to do this for this little demo. I have decided to go on the vector. Oh, this is like asking me to set up a new one. So when you set up your vectors, oh, go ahead.
And can I just say, like, I think, you know, we're heading into the Q&A section, but maybe can you just basically explain?
I'll blast through the rest.
Yeah, just explain what it means and what it's going to be doing, what it'll do to the part. And then anyone who has questions, put them in the question function, because we'll be switching over to questions from you soon.
Yeah, we could talk for days. So I'm going to go over to the preview toolpaths, and what you're going to see is my big block here, and this is the material. Now it's yellow, but in reality it would be like maple or mahogany, whatever you want. When I select these different toolpath operations, it's using all the line work that I have in this. And actually, when you look at these arrows, this is it. This is the one that is selected in the 3D view. It's the profile one. And if I say preview that visible toolpath, we're going to see what the CNC does, and boom, there's my truss rod slot. So I've had it mill this truss rod slot 3/8 of an inch deep to fit the truss rods that I know I'll be using. And if I go to, zoom out a little bit and go to profile 2, there's a profile of my entire neck. So this one, if I preview that guy, bada bing, there's our profile. So we're halfway there, folks. Now, what I need to do, right, if we all know about fender necks, the slab, we need this little dip, this little shelf over here on the headstock area. So I want to make a pocket. So I just have this big fat rectangle because I don't really want to go through the trouble of programming, a pocket that fits just the exact neck. It would save me time in the long run, but this is just a demonstration. So again, if we preview that, we're going to see that I've had this clear out a 1/4 inch little shelf area where that headstock sort of transitions into being a headstock. But this could be even a little cooler, save us a little time. So what we can do is, and over here in my 2D view, if I zoom out a little bit, see this weird gray thing? This is an object. This is an actual STL file that I've imported out here, and that means that this isn't just simple line work. This is a surface, and it sort of represents this surface with this gradient. And if I switch back to Rhino, I can very quickly show you this quick little surface that I built, which I believe is right here. There's my extrusion. So what this extrusion is, and you'll see this little box represented even in the other CAD file, is that if I go to my perspective view here, you're going to see, okay, you're going to see that this is the curve in the headstock. Now this isn't an exact curve, I drew this in 3 seconds, but this is a surface that I'm going to use in conjunction here with my cam, and that's represented here. And when I go to that 3D view and I pick the 3D finish part thing, we're going to see that it does that little transition. So I probably needed to do some other little operation to get this a little more in line, or maybe I got something a little off there. But that's like the general flow of how I've now made this neck, and then I'm going to drill out some headstock holes. And these are just little pins because what I actually want to do is take a custom drill bit later that's perfectly sized for the tuner holes at 9/16. So I just drill little dots with a 16th inch bit or like a V-carve bit or something like that to mark especially holes, because CNC isn't the best at doing this. So if we just reset the preview and preview all our toolpaths, this is a shorthand version, a very quick version of the operations that the actual CNC will do in the real world. And that's what I love about this. And from there, I can export this file. Oh, there's my wedge. Export this file and take it to the machine.
Great, thank you. See, we have some questions coming in. I also see, you know, as you're talking, you're working, you know, in sort of an order of you know, in to out, or there's a specific order that you're doing this tool pathing in. Can you just describe a little bit of your thinking behind why you're doing it in that order?
In that order, yeah. Order of operations is really key because you don't want to cut something out and then have it, say, hang loose, or, you know, it's a really broad thing that you don't, you know, want to put, you just don't want to do the wrong thing first. The neck is maybe, it's a really simple, easy example. There's not too much you could screw up in that, but, you know, just trying to think. I don't know. It's important. One place where it's important is if you're really going for production, right? If you're using a CNC for production, your biggest challenge is tool changes. So when I was doing these, I would arrange all the operations with very similar radius bits. So all my half-inch operations, I try to group those together so there was few tool changes as possible. Because when I was doing all this stuff, the real goal was to take something that would take me like 10 hours to do, or you know, 6-8 hours to do, carve a whole body, you know, to the state where I can, you know, start sanding it or finish sanding it or something like that. Take that and have the machine get it there, or 80% of the way there, in like 3 hours. That's like where the machine is super useful. One of the questions that came in, technical question, are compound radius and less, you know, complex constant radius fretboards doable? Fret slots something that you use CNC for? This kind of stuff, CNC is great at this. Compound radius fretboards, really difficult to do by hand, like really hard. Really easy for the machine. It's nothing for the machine if you can just program what is a simple thing into the machine. So that's where the machine is really useful, because for me, it took me so long to get a really perfect compound radius fretboard. But if I can slap it on the machine that's 5 feet away and do something else, while it does that perfectly every time, then that's the win situation. And that's why a lot of guitar builders are almost instantly gravitating to CNC. The precision is there, and it's appealing even if you do have the skills to get there, because the time save and the effort save is huge.
And can you just explain what that is, compound radius and complex constant radius fretboards? Like, what does that look like?
So constant radius, well, this is sort of constant radius. Constant radius just means the radius stays the same, like from, we're getting into crazy time. So say you've got your fretboard here. Oh boy. Oh, I'm not screen sharing.
No, not anymore.
It's like, so yeah, you got your you've got your fretboard, and the fretboard is radius. There's a slight curvature to this fretboard all along its length. If you played a guitar, you'll know what I'm talking about. So if the radius here up at the nut area is the same as the radius down here at the bottom where it meets the body, that is a constant radius. If the radius up here is like 12 inches, say for like a guitar, and then it flattens out to 16 or 14 or something a little flatter, that's your compound radius. And that's what's really difficult to get, because a constant radius, you just get a radiused block with some sandpaper, and then boom, you're done. But if you're doing just sand straight, and it goes. If you're doing a complex radius, you have to start with one radius block at one end and sand a little bit, and then get your other radius block at the nut end and do a little bit. And you actually have to like melt them together, and it's very time consuming because you can easily mess that up. And if you do mess it up, you're going to severely mess up how the fretboard plays and how the instrument plays.
So we have another question about neck and body of the guitar. Do you have to mill both sides of the neck or body?
So when you're talking about like milling, like with a joiner planer, like for the actual stock of the body, for the material preparation, I would say yes. You want your material to be as flat as possible on both sides, and you want to make sure it's not twisted. You want it to be extremely rectangular. You want to match the perfection that this sort of program, needs, because the program works in very exact dimensions. This is going to be exactly 5 inches. So if your stuff is off, that could mean your registration in the machine is off, right? Now, Paul, if you're talking about CNC both sides,
yes,
that's where the decision comes in. That's maybe one of the cruxes of this webinar is, right, when to pick out when are you going to use this machine? Because I think it might be a mistake to use it for everything, or in some ways it's a mistake to use it for everything. And I'll also say that, when I talk about this, and I can show you guys some videos, this is just my personal process. And there are things I love about guitar building, especially the wood carving. Really, I think I'm in it for the wood carving. I'm in it to get a big shiny guitar at the end that people say, wow, you're so great. But the deep sort of Zen passion is the wood carving. And so, that's a feature that I want to do by hand. And it's also a feature that's really difficult to get with a machine. And maybe one of the limitations if you don't own your own machine is that, you might be slightly limited because a lot of operations, if you really want to get crazy, you have to leave the machine set up with specific jigs and things like that. So in some of these scenarios, some of the choices I make are because I don't own my own machine. But also not owning my own machine saves me like crazy money. And I don't even particularly have an environment where I could own a CNC machine. Right now I'm able to have a small basement shop and be a NextFab member and have access to an immense amount of technology and resources, so it's like a low ceiling or low overhead burden, but it really depends on people's scenario. You want to go full force, because again, I do this part-time, I do this because I love this, and I do this because I want to create these things and I have these projects that I want to complete. I don't want people to play them, but if you want to do business, my suggestion is start out at a place like NextFab, learn the technology, and if you really feel the need, get your own machine. But the original question is, do you CNC both sides? I'd say yes, especially if you're talking about like a P-base neck. You can totally have it carve both sides and save even more time. I can show you a video where it would be like really difficult to get the machine to do that, and that might explain some of this a little better. So I'm gonna like share something else, which is really just gonna be my home screen. Did you guys know I like Star Trek? So can you see what I'm doing here? I'm going to go to the Pichardo build, and I downloaded some of these pictures today, and I hope they show up. Yes. So this is a custom crazy build that I did for a buddy of mine, Rodrigo Pichardo. He's a local musician. He's a really great guy. I use a combination of CNC and handwork on this all the way through, and this is one of my first, really taking the machine to taking myself to the limit of what I felt I could do with this machine at the time. This is a couple of years ago. So I don't know if we can like preview all these things.
If you're able, we can also share this out too if people can't see it well.
Say it again.
We can share this out after the webinar also if people want.
Oh yeah. Wait, what the heck are you? Well, I don't know. So there's like a slow-mo video. I guess the machine's cutting some stuff. Probably trying to get fancy. There's a little bit of operations happening. There's the machine cutting some stuff. This is like not inverted. Oh! Well, that didn't quite work like how I wanted. But let me just start out with like this picture. All right, so here's a little foam prototype that I made. So I had my CAD file, and what I did first was make the thing out of really cheap foam. And this is the body, and that's mostly what I made on the CNC. So that's me just saying, like, how does this look? How does this feel? As you can see, the top and the back are both carved, and that's why I used the CNC. Because to get the top and the back fully carved and sort of like parallax lens carved like that, I do it by hand. It would take me so long. It would be really hard to get it exact. But the whole point was to get the CNC machine to do this operation really fast so I don't have to. So after I get that going, here's a picture of the block. Let's see if I can flip it. So it's like sideways, but this is just the block of wood that I'm going to pop on there. And then this is two-sided machining. So this is after I'm done the back half of the operation, and it looks like the bit dragged on the way in there a little bit or on the way out. So those are some of the things you got to watch out for. Here I've milled the pocket, the cavity for the base, and I've milled the whole back of the base. And what you can sort of see in the background over here is that I have a whole platen piece of wood on here that I carved out a rectangle that fits this piece of wood exactly. And so basically I can take this wood and flip it around in that pocket, and the goal is to keep my registration. And it worked really well. I would develop a different system in the future. So after that, you're going to do what's called flip machining. And, a lot of people ask, what is the crazy thing about two-sided machining? And my answer is that two-sided machining is just doing one-sided machining twice. But the key is the registration. So that's why I sort of built a pocket for this block of wood to fit into exactly, so that I can just re-register it at will. So here's the top, and you can see I think there was like a slight bit of blowout, so I quickly super glued and taped it, and it's fine. It's a very small section, and I knew that this whole thing was sort of going to get carved away in the end. But the whole thing here was to get get a result like this easily. Like, the goal was to sip coffee. If you look at the the invite video for this, it's really what I did the whole time this was being done, was drink coffee and monitor the machine and see that my program is coming out correctly, and then I'm going to get this result, and I can rely on this, right? I can take this to the bank in a lot of ways that I can't take my own work to the bank, because I have to do it again. I have to reach that level of perfection again. This machine, if I put this block on there the right way, it's all done. It's all there for me. So that's really what the crux is. So after we get that sort of cut out of this block of wood, there it is. I took it home. I'm able to then fit the neck blank that I made, and I made the neck by hand. So a lot of my necks, I make them by hand because people might want a custom carve to the neck, custom shape. Also, I think it's something I enjoy, and for this particular scenario, for a set neck guitar, that was really almost necessary. Because again, as you'll see, to carve the back area of this whole heel section on this bass with a CNC machine, you would have to do some really crazy mounting solutions, and you would really like kind of need to own your own machine, and I didn't have that at the time. So again, we're just working through some mock-ups, making sure the bridge is at the right height, getting some things fitted, making sure all the holes are properly drilled. I've got it all freed up, and I've probably just like block sanded the whole thing flat. And then here, I think I finally have the neck not glued in quite yet, but close enough. Big secret, you're going to see that this neck over here is Yellow Heart and Wenge with an ebony. And then I actually, because I built two of these, another benefit of the CNC, I built two bodies at the same time in the same day. So I was there for about 6 hours, and I did that body operation twice, and I got two bodies out of it. So I used one for the current project, and I just had one for anything I want to use it for later, which will probably be another bass for Rodrigo. And I'm literally developing a bolt-on version of this using that secondary right now, which is actually the thumbnail that I used. So quick neck swap to Yellow Heart and Paduk and Rosewood, and then we're carving. We're doing some stuff with hand routers and stuff like that. Am I like going crazy over time?
I think show us, I think like the end result, and also we can share some of these out. We have
Sure.
one more question that came in. If anyone has any others, we maybe have time for a few more.
Yeah. The V-Carve versus Fusion 360. Probably Fusion 360 is maybe technically better because it's baked in to Fusion 360. Fusion 360 is also like $800-900 or something, $700. It really depends. You know, if you wanted to say get a whole package thing where it's CAD and CAM, then Fusion 360 is definitely a great choice. Not to say that V-Carve doesn't have drafting and modeling tools. I can't say that they're truly on the level that Fusion 360 is going to provide. And that's mostly why I do all my CAD work and modeling work in Rhino, is because the workflow is very familiar with me, and it's a very powerful workflow, and I can get results that would be difficult or impossible with V-Carve. But V-Carve as a CAM tool for me is very useful, and then I can do some tweaking. So I just wanted to show you, like, I think I have a video somewhere. Oh, it's going to be like impossible to find, I think. Oh, maybe this is it. Yeah, this is it. So this is carving the neck, and let me just try and pause this for a sec here. This is me in the process of carving this neck by hand. I have it glued, the body glued onto the neck, the body that I CNC'd glued onto the neck, and what you're going to see is a really complex shape develop out of this that a CNC technically could achieve. But again, the mounting of this parallax dome body with this neck on it, you know, you can totally do it. It becomes a bit more complex, and there's some other, you know, caveats that go along with doing this copper operation. But again, you know, my years of experience working with my hands allow me to do an operation like this just as well as any CNC machine could. I can do it on the fly, and I can make creative decisions, and that's what I like. But even the line work that I'm going to go by, you can see very lightly drafted here, is from an acrylic laser cut template from the exact CAD file. So I'm still working with my CAD lines, but I'm working this by hand now. So I think this will show a good bit of this process. And this is just an angled grinder with a flap disc on it. That's what I used all day working at Ken Smith. Bass's, the Luthier's Deluxe tool. And as you can see, this tool takes off a massive amount of material really quickly. So, when people say, oh, CNCs are so much faster than people, I really hesitate that. But again, I have to do this operation, and it does, take a long time. So you're going to see me slowly work this thing into a refined shape. I got all kinds of scrapers, chisels, gouges, stuff that I'm using in here, getting smaller and smaller and smaller and smaller and smaller and smaller, and more detail until we get to our final result, which is somewhere around here. But and I probably have like a video somewhere. Yeah, there's the video. So there's the finished wire. So neck mostly done by hand, but with CAD line work and templates, laser cut templates all over the place. Body half CNC, half hand worked. All awesome and very purple. And there it is. So that's like the main result.
Wow. I think that was a really good example of just a process that you go through. And I really like, you talking about your thinking of why you don't have the CNC do everything.
It's not like it can't do it. It's the complexity involved with getting it to do it. And if you have the skills to do it yourself, then you can just bust out your chisels and just do it, You don't have to set up, because it does take a long time to get those things correct for the machine. And again, you got to come in, set the machine up, operate it, clean up, do these things.
So we're almost at the end of the webinar. I know it goes by quick, but I think, before we head off, I see Caleb, you have a question for Ryan. I'll forward that to him after, just asking about if this is something you can teach, or maybe you can give him some resources.
I'm really open to teaching it. Of course, I want to do it in conjunction with NextFab because NextFab is the only gig I like better than making guitars for myself. I really love the mission here, and I want to do more stuff like this, and I want to open that avenue up to people because I got really lucky, and those kinds of chances that I got, I don't think are always present for people. I kind of want to pay that back. So we shall see. And Jesse, good to see you. Thanks for showing up.
Thank you for coming. Any last, if people are interested in learning this stuff, what is some recommended resources?
Oh yeah.
What skills should people be focusing on? And I can send this out in the follow-up email to everybody who's on today.
I'm gonna look at my bookshelf here. My advice is to buy a book. Buy a book on guitar making. Go to stumac.com and buy a book on guitar making. If you want, I will be happy to provide a bunch of links and resources. It really depends on where you want to go. If you want to get really serious about it, my suggestion is buy a book, buy 3-5 books like I did. If you haven't done any woodworking, take basic woodworking classes. Learn the fundamentals because you'll need them. If you do have this stuff, think about how serious you want to be about it. There are schools out there. There are a lot of programs that can be anywhere from 6 months to a few years. Find a local teacher or a local person who can help you along the journey. If you've read enough, and you've taken enough woodworking classes, you should be able to start piecing these things together. And I think that's kind of one of the cool things about NextFab is you can kind of come in with half a clue or even like a quarter of a clue. And, you know, the people there will be like, oh, well, yeah, you want to use this machine. You would say, oh, you know, how do I get this neck? You know, if you're not using the machine, CNC machine, how do I cut a guitar neck out? And it's, oh yeah, well, take this to the bandsaw. We have these like a whole bevy of sanders. You know, there's a bunch of situations where I don't even use routers anymore because the oscillating spindle sander at NextFab is so beastly that it's faster. It's like faster than going to the router table because I have to sand it anyway on the cleanup. So it's like, oh, I'll just take this straight to this giant machine that I could never own. And like it just kind of changes that process. So so some of that, but yeah, educating yourself about it because it's you know, guitar making is nothing mysterious per se. The big challenge is that it's a lot of small steps and you have to do them in order or else you can build yourself into a hole, I guess to say, just a dead end. You know, you kind of have to take some steps backwards and stuff like that. But it's all part of learning as well. So, you know, if I showed you pictures of my first attempted guitar build, I'd be showing you broken scraps of wood that I destroyed. You know, but if I showed you my third, then you say, "Oh wow, that's legitimate." And it took me a while to get there.
Yeah, got to make a lot of mistakes before you you make the good stuff. Okay, I will share. I'll get some links from you, Ryan, after this, so we can send them out tomorrow. We are going to send out the recording to this. And for those of you who are interested in the next webinar, that's on September 18th. Actually, no, not September 18th. That is on, it's next month in November. And that's how to, you know, network at for your business and how to actually get your things sold and into stores. So we'll have more information about that. But thank you, Ryan, for coming. Those who are interested, I will send out his Instagram. So if you want to contact him, you can contact him through that. But thank you, everyone. And I know we're a little over time, so thanks for sticking with us.
They love it. And if you guys want, I'll even like throw in some CAD files and some 3D files. I have some Les Paul generic, some awesome Les Paul stuff that you guys can take away.
Great. Well, thanks everyone. Have a good day.
Cheers.
Bye.